Welcome to this presentation of Cerebral, the state controller with its own debugger. We're going to kick this presentation off by looking at the demo. That way you instantly see what makes Cerebral so powerful. Then we will move into some brief history on MVC and how we think about changing state in our applications today. Then we are going to look at some code, both in regards of using Cerebral in an app, but also how you would go about implementing your own custom Cerebral controller. Okay, so this is the Cerebral Demo. We are using the Todo's MVC app, and we are running this with React as a view layer and Immutable Store as the model layer. On the right side, you can see the Chrome DevTools with the the Cerebral debugger running and the console, the Chrome console below it. As we can see, it has already discovered a signal that has been triggered called route changed. And this route change signal has ran two different actions, set filter and set visible to do's. The set filter action ran a set mutation on the filter state and passed in the value completed. And that's because we are on the completed URL. And then set visible to do's, the set visible to do's action did a set mutation on visible to do's, which was an empty array. So what we can do now is do some changes here. I can type some text, and you can see that new signals are triggered, and we can see the actions and mutations. And what's really nice now is that you haven't looked at any of the code there, but you're starting to see how this application actually works and what it does when you do changes in the UI. And that's kind of cool. I can also add this to do, but since we're on the completed, we can't see it. So let's move to all. There it is. And that's basically the how we use signals, and we can see the signals. But now let's keep these signals around. So let me click that. Let me just reset everything. And when I now do changes, we can see that the signals are being kept around. So when I now use this slider, I can move back and forth in time. I've done something wrong with the mix in here, so that's what this warning is. But keep in mind, this is still in development. But as you can see, I could move back and forth in time, and I can even change the past. So if I hit enter here instead, now this is like the state, and I can move back and forth doing that instead. I can also refresh, and I'm right back where I was. And this is really excellent for development. You don't have to reproduce your state all the time. You can just produce it and keep it around. Okay, so let me just show you one more cool thing. Just going to reset everything here. Let's do some recording. So I'll do record, and and that's completed, and then I'll remove it. Okay. So what's going to happen now is that it's going to use the recorder, which is part of the Cerebral controller. So when I hit play now, it will just replay those signals, keeping the duration between these signals being triggered, but it's the same concept. What's really cool about this is that it can be used for many different things, like support, and maybe just you want to help a user and they can start recording and you can play it back on your own machine, and it can do lots of cool stuff with this. But yes, that's what I wanted to show you in the demo. So MVC, our beloved architecture used on the backend and later moved to the front end. Our applications work basically like this. The browser made a request to the server, which had a controller taking care of that request. The controller was, and still is, a router that uses one or multiple middleware to handle that request. The middleware would either do changes in the database or grab data from the database, depending on the request. Then it would produce some HTML, which was passed as a response to the browser. This HTML view would then do new requests using forms or URL changes to do new state changes to the database or get state from the database. The important thing to notice here is that the only place we had state was in the database, not in the controller and not in the view. When we moved this architecture to the front end, some confusion started on what a view, a model, and a controller really is. Some frameworks took a very traditional approach like Backbone, where the model is a reflection of some entity in your database. The router still had the same role, but it was no longer necessary to do all state changes through the router. It was possible to bypass it and do changes directly to the model. The role of a controller becomes this very loosely defined thing. We also started to notice that all the state we have in our applications are not just database entities. We have complex UIs that requires its own state. So we basically started putting state all over the place, in views, in controllers, and in our models. In the last year, a lot of things has happened in front-end architecture. Initially by Facebook with their efforts on React and Flux, but mostly the community. We have stopped thinking of our model layer as a reflection of our database. It is just a plain object representing everything from a list of users to the state that indicates if a model is open or not. This made things a lot easier to reason about as you know where to put all your state. There is no longer abstractions that wraps these simple data structures. They are as simple as JavaScript primitives, objects, and arrays. The controller layer got cleaned up and is now working a lot more like traditional MVC architecture. The view layer requests a state change to the controller layer, so it is no longer bypassing the controller. There is no application state in the view layer or the controller layer anymore. All major framework providers have agreed on the concept of components as the view layer. Components work much like a traditional view really, though they are highly optimized for rendering and they are a lot easier to compose. You could say a component works more like an HTML element, where a view was much more a description of a section of your page. So nobody really knew how MVC should work in the front end. But as we are seeing now, we are moving back to a more traditional approach in a very good way. What is missing though is the concept of flow. With traditional MVC and its controller middleware, you could compose how a request should be handled. Some front-end routers has this feature today, but as we know, not all state changes starts with a route change. So what Cerebral is trying to solve is exactly this. The controller layer should be one thing. It should take requests, handle them with reusable and pure middleware functions, which make state changes to your model. This request can come from anywhere really, including a router. So this is where I personally believe we went the wrong way. I do not think we should handle the router as a type of controller at all. It is just something requesting a state change. That said, the controller should still take the great things about our server-side routers and create a generic way to change the state of the application. As you saw in the demo, this approach opens up new possibilities. So here we are looking at a list of signals. What you might notice first there is the name of these signals. They are not like actions. The view layer does not tell the controller layer what to do. The view layer just says, this is what happened in the view layer, and the controller then decides what is going to happen in regards of state changes. So we have new to do title changed, we have new to do submitted, remove to do clicked, and so on. So each of these signals has kind of middlewares or actions as they're called in Cerebral. So the first signal here is has just one action called set new to do title, while the second one has more actions, and they all happen in order. So first add to do, then set visible to do's, set all checked, and so on. What we also can see here is that one of these actions are put inside an array, and that means that the action should run asynchronously. So what that means is that if I would put more actions inside this array, they would all run in parallel. But they will not, the next action will not be triggered until all these async actions have completed, either being rejected or resolved. What is also important to notice here is how we reuse the actions. So for example, set visible to do's is used all over these signals. So it's very easy to reuse the actions. I also wanted to point out the route changed signal. So the router does not control the state of the application directly. It just indicates that something happened, like a route actually changed, and then it's up to the controller to set the correct state of the application, which will then be reflected in the view layer. So it just, in this case, on the to-do MVC, it sets the filter, and then it sets the correct visible to-dos based on that filter. So let's jump into one of these actions. Let's look at new to-do title changed and set new to-do title. So what happens here is that it's just a pure function. It receives two arguments. The first argument is called the args argument, and the second is called state. So args will receive initially the arguments passed into the signal when it's triggered. In this case, it's an object with a title property, and that will be merged into this args object. What's very nice about that is if I would, for example, return foo bar here, the next action would still have access to args.title and also args.foo. So it just makes it easier to access arguments across actions. The state object just has a few methods. One method is getting state from your state store or your state model. And the other methods are mutations. So in this case, we are just saying, okay, do a set mutation on the new to-do title state and insert the title from the arguments. If we move over to the save to do action, this is an asynchronous action. As stated earlier, that is because it's being used inside an array in the signal definition. So here we receive a third argument called promise. So this is, well, it's a promise, and all you have to do is either resolve or reject that promise at some point in time. So in this case, we are actually getting a to do from the to-dos object inside our state store. And then I'm just using a timeout just to simulate asynchronicity, and then I resolve with a value. So in this case, if I was using some kind of Ajax library, I could do promise.reject instead, and we could have an error here, for example. So that's basically how you would go about creating these signals, and you create all these actions that are very easily tested because they are pure. You can just pass in any kind of arguments of args object or state object and check if the correct mutations are done and so on. So when you're going to choose a type of cerebral controller, you can either build one yourself, choosing whatever state store you want and view layer you want. But you can also use the predefined packages. So I'm just going to show you how the Cerebral with React and immutable store is created. just to inspire you to build something yourself. So what I've done here is that I'm getting the core Cerebral controller and React and the immutable store, and I've also chosen to use an event emitter to notify about changes in state. The value function here, extracted from Cerebral, is just a helper function to make it easier to get values from the store. Because when you are going to do a state change, you want to use, sometimes you just use a string, like we saw on the set new to do title. But that is because it's on the top level of the store. If there's a nested level, you want to use an array, saying like the array is strings, where the first string is admin and the second string is new to do title, for example. So it just makes it easier to extract values from the store. So what I'm doing here is I'm defining a factory function. So this package is just a function. So you trigger a function, you pass in the initial state, and you can also pass in some default arguments, which will be part of all signals when they trigger. That is good for like having some kind of utility stuff like in Ajax library or whatever. So what we're doing here is that we're creating the initial state by creating a store and passing in the initial state passed in for the application. And then we redefine the state here as the initial state. So we keep this initial state around, and then we set the actual state to the initial state. And you will see very soon why we do that. Then we create a controller, and we pass in the default arguments, and we define an onReset method. This is something the debugger uses to replay the signals and set the application in the correct state. And this is very easy to do with the mutable store. We just say that, okay, now the state should be the initial state, and we're actually done. We also have an onSeek method, which is used by the recorder. So whenever you try to play back a recording, this function will trigger. And what it does is that it requires you to put the state from the recording, the initial state from the recording, into the current state. Now, immutable store has a method called import, which basically just takes the state from the recording and merges it in with the current state of the store. And then it just emits a change event, passing the new state of the whole store. Then we also need to indicate what should happen whenever there's like a signal is done, has done all its chained actions, when all the chained actions are done, or other types of updates that would require the UI to update. In this case, we are just going to emit a change event passing the current state of the store. Then we define the get method, and the argument here is always an array. So in this case, whatever is passed to the get method used inside actions will become an array, and we can use this value helper function to use that path with the current state, and then it will just return that value. Then we have multiple of these mutation methods, like onSet. So onSet, you get the path, but since the set method has a path and a key, we just grab that last path key from the path so that we can use this correctly. The thing is that this is low level stuff, and you have these hooks to do mutations, and depending on what kind of state store you're using, you have to do this differently. So this is just how you would do it with a mutable store. And again, we have all these different mutations. You don't have to implement all of them, but they are like this mutation methods we're used to in JavaScript, so they're nice to have. So when that's done, I've created an extra method on this controller for this Cerebral package. And it's just a way to inject the controller into the application using React context. And then we have some other things specifically for React, like if you want to use a mixin, you can do that here. If you want to use a decorator, you can do that there. Or a higher order component. This is basic React stuff. But now you see how little it requires to implement a controller using a specific view layer and a specific store or model layer. So that's basically what I wanted to show you. So now you've gotten some insight into why Cerebral was built and what it can do and how you can use it and how you can customize it for your own needs. Cerebral is currently still in development, but feel free to start checking it out. The documentation is quite good so far, but it can certainly be better. Again, I hope you liked it and you will check out Cerebral.